Hey guys, in this video we're going to be taking a look at the congruent parts of congruent triangle congruence theorem. You'll most commonly hear it referred to as the CPCTC. What I would strongly suggest is that whenever you see this abbreviation, you still think of this, because I've found that over the years that whenever I teach this to students, if all they do is see this and think about this, they forget what it does for them whenever they're trying to solve and prove things for a triangle. So when you see this, be sure you're thinking congruent parts of congruent triangles congruence theorem. And what that will do for you is it tells you if you have two triangles that are congruent, then each part of one triangle is going to be congruent to the corresponding part of another triangle. So what that says is if they tell you, you have to be told, or you have to prove. And that's what you see down here. In order to use the corresponding parts of congruent triangles, you have to be told or show that the two triangles are congruent first. And only after you've been shown or told that the triangles are congruent, then you can state that the parts are congruent. So for this example up here, you would have to be told ABC is congruent to triangle DEF. So if you are told, or you can prove that, then you can say that angle A is congruent to angle B, and angle A is congruent to angle D. Angle A is congruent to angle D, and angle B is going to be congruent to angle E, and angle C is going to be congruent to angle F. So that's all your angles that you can say are congruent to each other. You can also say that side AB is going to be congruent to side DE, and then you can say that side BC is going to be congruent to side EF. You can also say that side CA is going to be congruent to side FD. So if you're told or you can prove that the two triangles are congruent, then any of these 6 statements are available to be used to show whatever you need to show. Yeah. Looking at the first example that we have, they tell us that RT is congruent to RV. So I'm going to go ahead and mark that in the picture. RT congruent to RV, that's a given. So RT is right here. Is congruent to RV through right there. And they want us to complete the proof to show that RS is congruent to RW. So let's see, RS and RW is what we're looking for. All right, so in order to be able to say that those two parts of the triangles are congruent to each other, we have to first show that the two triangles are congruent, and you can see where they did that right there. So what they want us to do for this proof is to go ahead and fill in the blank for what we have there. So they want us to say why those two triangles are congruent. So if we look at the information that they give us, here's a side to side that we have right there. So if we're thinking of that list of 4 things that we have that we can use to show that triangles are congruent, it's going to be side, 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 angle, side, angle, side, angle, or angle, angle, side. So those are our 4 options of what we could be using to show that they are congruent. So there's one side right there. So then looking here, they give us angle T congruent to angle V. They know that's given because the angles are marked in the picture, so that will make the first angle right there. So it's probably not going to be side, side, side. So that means we either need to find another side or another angle. And here they gave us the other angle. So they've got angle R is congruent to angle R. So looking at the two triangles that they give us RSV. So RSV. And the reason why I'm outlining is because we need to be able to tell which parts we're looking at, whether it's a side angle side and the angle is included, or if it's an angle side angle and the side's included, or if the side's not included, it's going to be angle angle side. So focusing on the triangles will help tell us which theorem it's going to be. Okay, so if we look at the blue triangle, here's an angle there, there's a side there, there's an angle there. So this right here gave us our second angle. So two angles and a side, we're deciding between those two, so we need to figure out if the side's included. So there's an angle, there's a side, there's an angle, just double checking the other triangle, here's an angle, here's a side, there's an angle right there. So it's going to be angle side angle, congruency. And then once you show that the two triangles are congruent, you can say any of their parts in the congruency statement are congruent. So here they go RS, there's the RS, and they go RW, there's the RW right there. Alrighty, looking at the next proof that we have. They want us to complete the proof to say that TZ is going to be congruent to VW. TZ, VW. And within that, they tell us that angle TXZ is congruent to angle VYW. So TXZ, VYW. So it tells us those two angles are congruent. Looking next, they tell us angle V is congruent to angle T, and that's another given. So already I'm starting to think through that list. Is this going to be side, 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 angle, angle, or angle, angle, side? Since we just identified two angles, I'm thinking it's probably going to be one of those two. So then looking at the next statement, they tell us that YZ is congruent to WX, YZ congruent to WX, YZ is right there, is congruent to WX right there. So whereas the last two statements gave us, this right here is angles and triangles. So we have one angles and triangles and a second pair of angles and triangles. These aren't whole entire sides for those triangles. If we're looking at triangle TXZ and VYW, those are only portions of the sides. So we would have to do segment addition postulate or the additive property of length. Either of those two are the same to get that third one in there. And that's what they go in here and do. They do XZ. So this whole side right here is going to be equal to YZ plus XY. So that whole side is going to be equal to YZ plus XY to give us additive property of length. So then they do this with the next one. WY is going to be equal to the sum of its parts, WX plus XY. And it's going to be the same exact reasoning there. Additive property of length. So our goal is to make it so that ZX is congruent to WY. So there's us a ZX or a XZ and a WY there. We can't put them equal because even though we have the XYs that are the same there, the WX and the YZ are not the same. So instead of a YZ, we want to write a WX. That way they're going to be both the same. So we took step 4 and rewrote it in step 6 so that instead of YZ we had a WX, and when we do instead of something we write something else, that's going to be substitution. So now that we have said that these two values are the same, there's the WX is the same, there's the XYs that are same. Since these two statements are the same, we can say that the two things that they are equal to are the same as well. So WY is going to be congruent to XZ, so that hole right there is congruent to that hole right there. And that's either the transfer property or substitution is what I always put in for these, and it takes it just fine. And so from there, they say those two triangles are congruent based on angle-angle side similarity, because here's an angle in one triangle, there's the second angle in the triangle, there's the side, there's the angle on the second triangle, the second angle on the second triangle, and the side. The side is not between those two sets of angles, so that's going to make it be angle-angle side congruency. And then once we have two triangles are congruent, we can say that the parts that make them up are congruent, and that's what we're looking at for this one right there. Right there we've got TZ and WV. TZ right there, WV there, the letters match up. So we can say that TZ is going to be congruent to VW by congruent parts of congruent triangles are congruent. Looking at the next one, complete the proof that angle U is congruent to angle T. These can be kind of tricky. If you have trouble seeing these, try drawing them out as two separate triangles and see if that helps. Otherwise, just go with what you've been given. So this one, they say SU is congruent to ST. So here's SU and there's ST, and those two are congruent to each other. We know that because it's given in the picture. The next thing, so that gives us two sides to work with. So thinking of that list, we've got side, 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 angle, side, angle, side, angle, and angle, angle, side. So since we have two sides that we're working with in this triangle, it's probably going to be one of those two, either side, 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 or side, angle, side. But if you look at the next step, they give you an angle. So angle S is congruent to angle S, and that's going to be our reflexive property of congruence. And that's the same thing is equal to same thing, so that makes it be reflexive. So with that, we have two sides and an angle to match up. So that'll give us triangle STU is congruent to triangle SUT, side, angle, side. And once we're able to show that the two triangles are congruent, then we can say that their corresponding parts are also going to be congruent. So angle U being equal to angle T is because of these two triangles being congruent there. And one thing you can always do is just double check. Does the U actually match up with T? It does, so that's how we know for sure that what we have written for our triangle congruence statement will work. So corresponding parts of congruent triangles are congruent. Looking at the next one, a little bit more of a fill in the blank. So this one tells us that FI bisects angle GIK. So line FI bisects GIK. So that tells me that angle right there is equal to incongruent to that angle right there. And since this is going to be a fill in the blank proof, I'm just going to go ahead and mark this as given. And at the same time, I'm going to find the angles that are congruent here. So I'm looking for angle KIF is congruent to angle GIF. So J, no. So FIK congruent to FIG. Yep, there's our angle right there that we were looking for, and we know those two angles are going to be congruent because of the definition of an angle bisector theorem. I was double checking my list. Moving on to the next one they give us, they tell us that line FI bisects angle HFJ. So HFJ bisects it, so that means this angle right there is going to be congruent to that angle right there. So there's the FI bisects angle HFJ. So that's going to be given. So we're looking at JFI. Nope. There's the JFI is congruent to HFI. So there's that congruency statement. So those two angles are going to be congruent because of definition of angle bisector. Looking at the next part that they give us, they tell us that angle JIK is going to be congruent to GIH. So, and with these proofs, you have to be really careful when they get long like this. You can't just assume that the first couple things that you come up with are going to be are going to be the actual sides and angles that you used. And I forgot to label this one right here. This was our first side that we were working with there. See how this one I didn't label it as a side. You can't assume that the first things that you come up with are going to be the sides and the angles that you're using to prove that the two triangles are congruent. It was easier to do in the last couple lessons because the proofs were shorter and there wasn't as much going on. With these, there's a lot of things and values that are going on, and you've got to make sure to look and say, am I actually working with a triangle? And are these parts of the triangle that we're trying to show are congruent to each other? So just be very careful with these. So we've got JIK is going to be congruent to GIH. So that angle is congruent to that angle, and that's going to be our vertical angle theorem because those two angles are vertical angles. So we're trying to prove that HI is congruent to IJ. So let's find those. HI is right there. Is going to be congruent to IJ. So right now I'm trying to focus on finding the triangle. Well, if this were a proof where we would have to write it out and fill in the blanks, we would have to work through the reasoning and figure out what it is. But these are really nice because it tells you straight up what they're going to be. So we've got FIH is one of the triangles. And then the other triangle that we're working with is FIJ. Okay, so that makes it a lot easier to be able to kind of get a gist of where we're going. Here's an angle in this triangle, and that's the whole total angle, and so we've got those two congruent to each other. So that tells us that this angle statement right here, that's going to be one of our angles that we use to show congruency. Well, looking at those two angles in this triangle and those two triangles in the second triangle, those are going to be the exact same length, but we don't have one whole entire angle that's the same length. So we want to put both of those angles together to be equal to that whole big angle that's making up those angles right there. So we're looking for FIH or HIF. Here's FIH. So here's where they've got FIH is going to be equal to FIG plus GIH. So that'll give us that whole big angle in there. So that'll give us that angle. And that is going to be our additive property of angle measure to put those two together. So if they're going to do that with that angle, we better be doing it with the other one. So look at it. Fij is going to be made up of Fik plus Jik. So there's that angle addition postulate right there, or the additive property of angle measures. So that'll give us that angle there and this angle right there. So now we've got two angles, two pairs of angles. So I'm thinking through that list. Side, 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 angle, side, angle, side, angle, or angle, angle, side. So I'm thinking because they give us two angles to work with, it's probably going to be one of those two. So they show that those two add up, and then they go through and they're wanting to say, once you have the angles as the whole total angles, they go through and we have to make those two angles equal to each other. So in order to be able to make them equal to each other, we would have to have these be the exact same statement. So they're both completely different. So looks like they're keeping the Fij, and instead of the Fik, they're replacing it with a Fig. And instead of a Jik, they're going to replace it with a GIH. So they did two substitutions in that one. But no matter how many they do, it's still considered substitution. So this is instead of this, they wrote that, and instead of this, they wrote that for substitution. And then once they're able to say that, or show that those two parts that add up to make those are the same value, they can say that those two angles are equal to each other. And that's just going to be another substitution. So now they've said that that angle is equal to that angle. So now we're looking for where the side's going to be. And the side that they use is Fi. So they say Fi is congruent to Fi, and that's in the same exact spot. So they overlap, which makes that be the reflexive property of congruence. So then now we have an angle, a side, and an angle for that pink triangle, and an angle and a side and an angle for the blue triangle. So that's going to make that be angle, side, angle, congruence. So now that we've shown that those two triangles are congruent, we can say that any and all of their parts of them are going to be congruent as well. So we're looking at that side congruent to that side, and double checking the congruence statement that they give us. Does HI really match up with IJ? So this is going to be corresponding parts of congruent triangle congruency. Looking at the last one. You could get a couple towards the end. You could get a couple of fill in the blank, and this is for the statements, and this is an example of one of those. So starting off with our given, we're told Vx is congruent to Wy. Vx, Wy given. Vx, so that side right there, Wy. And then the next part that they give us is angle VWY is going to be congruent to angle WVX. That's another given. They showed that in the picture. And then here they say WV is parallel to XY. And I'm extending them and making them dashed lines. I'm going to highlight the little arrows to help remind me that those sides are not congruent, but that they're parallel. All right, so where do they go next? They say angle WVX is going to be congruent to VXY. So if I'm looking at that one, there's an angle there, there's an angle there. They're on opposite sides of that line, and they're between the two parallel lines. So that's going to be alternate interior angle theorem. Looking at the next one they give us, angle WYX. So that angle right there is going to be congruent to VWY, so that angle right there, by the alternate interior angle theorem. So we're looking angle there, angle there, angle there, and angle there. Moving on to the next one, we've got angle VWY. VWY is going to be congruent to VXY. So those two are going to be congruent. So VXY was right here. And instead of a VXY, they kept it. And instead of a WVX, they rewrote VXY. And they got it from this one right there. So that's they wrote that as transitive property of congruence. That one could also be substitution. And then looking at the next one, they've kept the VXY, but instead of the angle VWY, they've replaced it with a angle WVX, so that comes from this statement right here. And again, it's instead of this, we write that. So that's going to be our substitution property. So now we're looking for where those triangles are, and I forgot to mark these. So WYX, so this angle right here is going to be congruent to VXY, that triangle right there. And then looking at this one, VWY is going to be congruent to VXY. So if I'm looking for those triangles, I've got triangle VXY because we're looking at this angle right there. And then we're looking at triangle WYX. So that gives me those two angles right there. So thinking through the list of things that we have, we could have side, 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 angle, side, angle, side, angle, and angle, angle, side. So looking here, we've got an angle there. So that means we're probably going to be working with one of the three with an angle in it. So then I'm looking for other values. Did they say anything about XWY? No, I'm not seeing anything about XWY. The whole thing is a total. So then, what's the next thing they give us to work with? We know for sure this is going to be one of them because that's the angles there. So there's one of our angles there. And then looking for where that second angle is. So WYX we already have. VXY we already have. So VWY is on the outside. VXY is on the inside, but it's only that little part. And then WVX. So that angle right there going to angle VXY. That's that angle there. So that's not going to work. And then VWY. Well, I know for sure that they've got an overlapping side there. So at the very least, we've got XY is going to be congruent to XY, and that's going to give us one side to be working with, and that's going to be our reflexive property of congruence. So it's looking like none of the angles are really going to work. So back up here to the top, they give us the side. They tell us that WY is congruent to VX. So that gives us that front side on both of those. So this gives us, well, we saw it last, but that'll give us our second side right there to go with those triangles. So now it's a matter of determining whether that angle is going to be between those two sides or on the other side. Just kind of a reference for you. Think about what the abbreviation would be if we had angle side congruency. You got that abbreviation? Yeah, that'll get us both in trouble if we're using that one. So that's one way that I remember that angle side's never okay to use whenever we're doing these proofs. Because if that were to get written on a piece of paper, you and I both would probably get in trouble for that. So that's why we don't do that one. So then it's probably going to be a side angle side congruency. So if we're writing the triangle congruence, we're going to go triangle. Let's start with VXY is going to be congruent to triangle. So if we're going VXY, it's got to go WYX. And that's going to be side angle side congruence. So now that we've shown those two triangles are congruent to each other, we can say that any of their parts that make them up are going to be congruent as well. So WX is going to be congruent to VY. So if we're looking to match up the parts, WX congruent to VY. So first, third, so we're doing okay. And the reason why those are going to be congruent is congruent parts of congruent triangles are congruent. So that's an example of a fill in the blank where you're using your side angle side. Ooh, and looking at this one, I'm mislabeling the side and the angle there. So there's the side that they use right there. And then the other angle that they use is the FIH. So there's the second angle there. And so that'll give you that angle side angle for that proof. And then there's your side angle side congruency and angle side. And then there's another angle side angle congruency. So you've got several different proofs with several different types of pictures and things going on in situations that you could see for how to prove parts or triangles are congruent to each other. And remember, the big thing to do with these is you have to be either told or show that the two triangles are congruent first, and then you're going to be able to use that congruent parts of congruent triangles are congruent. If you have any questions, be sure to write them down and ask when you get to class.